Colour or tone mapping is an internal process that V-Ray uses in order to map the colour values found in our rendered pixels, affecting the way in which the brightest and darkest colours are represented. The process has a number of similarities to a camera's exposure control, or even the response of the human eye to light levels found in an environment, given that colour mapping is designed to map the colours rendered internally by V-Ray to a range that is both usable and viewable by the rendering artist. Of course, colour mapping in some form or another is something that all render engines have to do internally, because without this final translation of collected information to usable pixel colour values, we wouldn't get anything in the way of pleasing images out of our render engines. One of the potentially useful things about the way in which V-Ray goes about things, though, is the fact that it allows us to make some pre-render choices regarding how the colour mapping process is to work. This gives us the ability to determine in advance, at least to a certain extent, how our final renders are going to look. Now, before we, in our next video, walk through a brief description and comparison of the colour mapping types available, looking at how they affect our rendered images, I just want to take a quick look here at some of the colour mapping controls available. To do that, we will of course need to open up the Options dialog and come into the colour mapping rollout. Now, we have already discussed the linear workflow checkbox here, and hopefully have debunked some of the misinformation that has grown up around it. What we haven't discussed, however, is how we actually go about setting up the controls here should we want to work with a genuine end-to-end linear workflow pipeline. That is, to render and output linear images from SketchUp that we can then take and manipulate in linear space in a compositing application such as After Effects, Fusion or Nuke, only outputting a gamma-corrected version of the image right at the end of the production pipeline. Well, the setup is quite simple really, seeing as all we need to do is put a check in the Don't Affect Colours checkbox, set our colour mapping mode to Linear Multiply, and then on the V-Ray frame buffer window, make certain that we view our renders with the sRGB toggle enabled, assuming that is we want to see what the render will ultimately look like once it has been gamma-corrected in post. Of course, we will also need to keep in mind that if we want to carry a genuine linear workflow into our compositing application, then we will need to make certain that we save our V-Ray renders to floating point image file formats such as .exr or .hdr. Another colour mapping option I would like to touch on here is the Clamp Output checkbox. When turned on, this option caps, or as it says, clamps pixel brightness values to the value specified in the numeric field here. Enabling this will have an unseen and yet impactful effect on our renders. For one thing, any images containing very bright areas will probably render a little faster. This would be due to the fact that fewer image samples will be required now that there are no super bright pixels in the image that need to be anti-aliased, assuming of course that we clamp our images to a value of 1.0 or lower. Now, whilst using the clamp option doesn't prevent us saving our renders to floating point image files, meaning we could still, in post-production, push the exposure back into the super bright range, what we will have to keep in mind is the fact that clamping in V-Ray will limit the dynamic range or contrast ratio that our image pixels now contain. Whilst this may not be a big deal on some projects, there may be others where this could cause problems once we get into the post-production phase. The final option I want to quickly look at here is sub-pixel mapping. This option controls whether or not the colour mapping mode and settings that we choose get applied to the final rendered pixels in an image or to the sub-pixel samples from which the final pixel colours will be constructed. The difference in look produced by the two operations is usually very subtle, if in fact it can be noticed at all, although working with sub-pixel mapping off is thought by Chaos Group to produce a more accurate looking final render. One problem this option can on occasion help with is that of fireflies or bright speckles in an image that typically exist due to super bright areas receiving insufficient samples or rays in order to be resolved correctly. In our next exercise then, we can move on and make an examination of just how the various colour mapping modes available actually affect our final rendered images.